So some of the problems that you're going to see in your homework will be based off of these concepts from quadratics. So let's just look at this first one. Coach Roberts has a device that launches baseballs into the air so the outfielders can practice catching pop-ups. So that's more of background. If it launches a ball with a velocity of 105 feet per second, so let's see, velocity is 105 feet per second. I always like to write down what my knowns are. After how many seconds will the ball be at a height of 140 feet above the ground? So they want the height to be 140, not 160. 140 feet above the ground. It's 140 feet, okay? Or we can say feet if you're wanting to use feet. Use the equation for projectile motion. H equals negative 16 t squared plus v naught t, where h is the height of the ball, t seconds after it is launched at an initial velocity of v naught. Enter multiple answers separated by a comma and round all your answers to one decimal place. So our velocity, that is our v naught. That's our initial. That's what that little zero means. That means initial velocity. Okay. So that's the initial velocity when they launch the ball. Okay. This is the height in feet. And they give us this formula, h equals negative 16 t squared plus v naught t, where t is our time in seconds. Okay. Now, where does this formula come from? Well, this formula comes from gravity. Okay, this is the actual formula. So if you have some height, okay, maybe it's a building, and we launch something, it's going to travel. Say it goes up and it comes back down. It's going to travel at negative 16 t squared plus v naught t. So that's the initial velocity. Now we could launch it from a building. We could launch it from the ground. It really doesn't matter. Okay. It could be launched from over here and it could be launched all the way up. And it will go to some height, some maximum, that's our maximum height up here, which we're going to see in another problem. But it follows this formula because no matter what you launch, again, this is assuming Earth, it's going to fall back to the Earth at that gravitational negative 16 when we're talking in feet and seconds. Okay, if we were talking meters per second, then it would be 9.8. But we're talking feet, so we're going to use the negative 16 t squared plus v naught t. Okay, so let's see what we have. Our h here was 140. Okay, so that was our h equals our negative 16 t squared plus v naught t. Okay, well, let's see, negative 16 t squared plus my v naught, that would be my 105 feet per second times my time. Okay, now, because we know that this is our formula using that height equals negative 16 t squared plus v naught t, this is almost in that quadratic formula. I'm sorry, that's ax squared. Ax squared plus bx plus c equals 0 form. So really the only thing we need to do is move this 140 over. So let's subtract 140 from both sides. And we end up with 0 equals negative 16 t squared plus 105 t, that's that feet per second above the ground, minus 140, that's our height, and that gives us that quadratic. Now we could say it's equal to 0 over here. It really doesn't matter where the 0 is. I just put it in line with that. Okay. Now let's see, my a here is negative 16 because that's with my x squared. In this case, instead of using x, I can use t. Okay. Because that also works. This is just the variable. Instead of x, I can use t for time. Okay. B here is 105, and C is equal to negative 140. So let's see, my T this time, instead of saying my X equals the opposite of B plus or minus square root of B squared minus 4AC all over 2A, I'm going to use T, right? So let me erase that. Instead of saying X, I can use T. It still works out to be the same. So this is the opposite of my B term, which is 105, plus or minus the square root of my B squared minus 4 times A times C, which is negative 140, all divided by 2 times A. Oops, but I know what A is, so I can go ahead and write that in there. So that's negative 16. Okay? All right. So let's see what we have. T is equal to negative negative of, sorry, 105. Sorry, I lost what I was doing there for a second. Let's see, plus or minus the square root of my 105 quantity squared. It might have made sense had we moved these over to this side instead of this over to that side, so we'd have our negative 105 here. It really doesn't matter. It should still work out for us. Actually, I think I do want to do that. Oh, I guess it really doesn't matter. It really does not matter. Okay, 105 squared is 1,100. I'm sorry, 11,025. Minus is going to be minus 4 times 16 times 140 is 8,960. I'm not going to do that one in my head. And then 2 times negative 16 is negative 32. Okay. All right, so let's see, negative 105 plus or minus the square root of 11,025 minus 8,960 gives me 2,065, and this is divided by negative 32. Okay, so T is equal to negative 105 minus the square root of 2065 over negative 32, and negative 105 plus the square root of 2065 divided by negative 32. Okay, now when I have those two answers, let's see, let's see, T is going to equal, when I do this math, okay, negative 105 minus the square root of 2065 divided by negative 32, that's going to give me approximately, when I do this math, 1.9 seconds. And then when I do negative 105 plus the square root of 2065, hit enter, then divide by negative 32 is going to give me 4.7 seconds. Okay. So what we're going to say is the ball reaches the height of 140 feet after approximately 1.9 seconds and 4.7 seconds. Okay. So that should, if you think about this, when we're launching the ball and we want to know the time at which it's going to be a height of 140, so maybe the height here is 140, so that's going to happen at this time here and at that time there. Okay. Another way you can think of this is if we were to graph out this function, what we end up with is, actually, let me not draw it that quite that way. Oops, that should be an eraser. Okay, let me actually see if I can share this screen. Give me a second. Let me stop sharing for a second and let me share Um, hold on a second. Let me come over here and go to Desmos. Desmos graphing. And let me go back to my Zoom meeting and let me share my Desmos screen. Oh, okay. Let's say we have that function and I have negative 16. I'm going to use x for this, x squared plus 105x minus 140. Okay. If I zoom out, there's that 1.86 seconds, 4.7. It kind of looks like that if I were to graph it out. Okay. And let's go back to what I originally had. So this was 1.86, which is about 1.9, and that 4.7 seconds. Okay. So let's go back to my share, and I'm going to go back to bamboo paper. I'm going to share that. So again, there's my 1.9 seconds or 1.86 and that 4.7 seconds. Okay. All right. If you're having trouble calculating this, what I suggest doing is do this negative 105 minus the square root of 2065, find out what that number is, then divide by negative 32, and the same thing with this side. Okay. All right, let's look at another problem. Okay. Cannonball this time is fired directly upward with an initial velocity of 580 feet per second. So this is our V naught, which is that 580 feet per second. Its height above the ground at time t can be modeled with that equation, so they gave that to us. So h is equal to negative 16 t squared plus 580 t. And it says, how high does the cannonball travel before it begins to fall back to the ground? Round your answer to 2 decimal places as needed. Okay, so the first thing that we need to do is figure out what the maximum of that function becomes. So remember, it'll kind of look like that, okay? So to find that maximum here, what we need is the this formula, okay? And that formula is going to give us our t, okay? So x is equal to the opposite of b over 2a, or t is equal to the opposite of b over 2a, okay? That's our time that it takes to get to the maximum. Or if we had a parabola that looked like that, that would be the minimum time. This is the maximum time. This would be the minimum time. So that t is equal to the opposite of b over 2a. So let's plug in what we have. So t is equal to 580. That's our opposite of our b over our 2 times our a, which is negative 16. Okay. Negative over negative is positive. Okay. And that this is going to give us that amount of time that it takes, because obviously it has to be positive to get our answer. So it doesn't matter. This would always have to be positive. Okay. If we were to put this in that ax squared plus bx plus c form equals 0, we would move this to the other side, leaving us with a positive 16t squared minus 580t, and then plus our height equals 0. Okay, so that's where we would get that. Okay. All right, so let's go back to this. So 580 divided by 2 times 16 gives us approximately 18.125 seconds. Okay, that is not our answer. They want to know how high the ball gets. So h is equal to negative 16 times our time, which is that 18.125 seconds squared, plus my 580 times that 18.125 seconds. And that's going to give us the height. Okay, so doing this math, we end up with approximately a height of 5,256.25 feet. Okay, so we would square this, multiply it by our negative 16, and then add 580 times our 18.125. Okay, so that gives us approximately, by the way, this is approximate, that is also approximate. Okay, either symbol works for approximately. Okay, so the height of this here, that would be the height at 5,256.25 feet. Okay, at our time is equal to 18.125 seconds. Okay, so after 18 seconds, it's going to be at a height of 5,256.25 feet. Okay, all right, and let's go to our next one. So it says a video goes viral on social media. It says the number of views per day can be modeled with the equation y equals negative 1.125 x squared plus 7.875 x. And it says where x is the number of days after the video is posted and y is the number of views per day in thousands. According to the model, after how many days do people stop watching the video? Okay, well, let's see. First, we need to know, so we have this y equals negative 1.125 plus 7.875x. So that's in that ax squared plus bx plus c form, okay, where this is negative 1.125 x squared plus 7.875x. Our c here would be 0, and that's going to be 0 here, okay? That's going to be our formula, or our in our standard form, sorry, where a is equal to negative 1.125, b is equal to 7.875, and c is equal to 0. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so let's see what happens here. X equals the opposite of b. So that's 7.875 plus or minus the square root of b squared, 7.875 quantity squared, times 4 or minus 4 times a, which is negative 1.125, times c, which is 0. This whole thing, when you multiply by 0, goes to 0 over 2 times negative 1.125. All right, so x equals negative 7.875 plus or minus the square root of, well, 7.875 quantity squared is 62.015625. Don't round this yet. Divided by 2 times negative 1.125 is negative 2.25. So let's see, x equals 3.5 plus or minus a negative 3.5. Okay, so that works out to be, oops, sorry, didn't mean to scratch that out. This works out to be x equals 0 and x equals 7, okay, when I do the math on this. 3.35 plus a negative 3.35 is 0. 3.35 minus a negative 3.35 is 7. Okay. So this means that this is our initial, that's right after the movie was released. So 0 people have watched the movie. And what it asks you is how many days do people stop watching the movie? So they stopped watching it at 7 days. So 7 days is the correct answer for that. Okay. So basically, if I were to graph that, it would look something like that. Okay. Where this is when people started watching at 0 and they stopped watching at 7 days. Okay. That's, if I were to graph that, that's kind of what that looks like. Okay. It's not exact, but you get the gist. Okay. All right. I hope that helps.